the response that God can solve it would always be available. Now, instead of taking bounded human cognitive capacities and idealizing them, I think the appropriate move is to consider instrumental extensions of our human abilities and the representational apparatuses that we need to make effective use of them. So the contrast I want to make is between the kind of position that those analytic metaphysicians that I gave the quotes from want to take human cognitive abilities, idealize them quite radically, and say that's the appropriate epistemological position for doing metaphysics, whereas I think that you should stay with the abilities that we have and then look at various ways in which they can be enhanced. I hope in ways that we can still have genuine access to the results of those methods. Now, one of the most important moves in the history of the formal sciences was the de-psychologizing of the conceptual apparatuses that are used in science and mathematics, moving them from the mental realm to linguistic frameworks. There has, as we know, been something of a return to psychologism in recent times. Most notably, I think, in the tradition that evolved from Quines epistemology naturalism. And I should say here that when one is talking about naturalised metaphysics, I want myself to distance what I'm doing from that tradition in naturalised epistemology. I think that term, valuable as it might have been, has far too much of a psychological content for my taste. Now, once we've allowed the a priori to no longer be tied to the psychological realm, even in an idealized sense, one reason for pursuing a scientifically informed metaphysics flows from the weakness of the unaided human imagination. Given that a considerable part of metaphysics requires considering non-actual possibilities, excuse me, any source that aids the construction of possibilities that have not yet been conceived should be welcomed. It might be thought that science is restricted to the development only of non-logical possibilities, but that's not correct. Because much theoretical and mathematical science involves the exploration of highly idealized models that are not, and in some cases could not be, realized in our world, that sort of activity broadens, at least modestly, the set of possibilities that we can represent. In addition, the ability to exploit worlds with different laws has been greatly increased with the easy availability of computer simulations. Very little of the logical space that's associated with dynamical systems theory over the last 3 decades would have been occupied without those computational methods. To take just one example, explorations of models of deterministic and quantum chaos have greatly increased our understanding of what the consequences of a deterministic position actually are. So, I think after that somewhat discursive rendering, I think we arrive at the second model for naturalized metaphysics, which is that all methods have their domains of applicability and associated probabilities of error. And given an application that falls into the domains of 2 methods, obviously one example here is unaided human intuition and detailed scientific theorizing, you should choose the method with a lower probability of epistemic error. And that certainly allows room for some domain of appropriateness of the sort of appeal to intuitions that analytic metaphysicians make. But I think it's very, very constrained. Many of the problems that arise from analytic metaphysics is in not recognizing the appropriate scope of those methods. Okay, so not going to come back. And yeah, okay, so that's, sorry, I got one slide. Okay. So, last section of the paper, where I want to, having addressed some of the concerns about analytic metaphysics, now talk about issues connected with Friedman's account of the a priori. Now, in order to avoid attempting to describe the indescribable, one of my central concerns has to be to capture what we can maintain across the transition from anthropocentric to non-anthropocentric representations of science. That is, what is going to happen once we start delegating many of our theoretical tasks to computational devices, which, as I described earlier, frequently use quite different conceptual or at least representational apparatuses than we are ordinarily familiar with. Such a radical transition might immediately bring to mind issues of incommensurability, but we can avoid such problems, at least initially, by confining our attention to purely formal representation apparatuses, since they have the possibility of acting invariantly on either side of the anthropocentric, non-anthropocentric divide. In the more specific realm of computational science, traditional computational algorithms can be recognized on either side of the divide by humans and by machines in a way that's reminiscent of the original motivation for structural realism, which was to capture mathematical representations that preserved across radical theory change. As a further restriction, I'm going to include, at least initially, only direct formal representations, where a direct formal representation is one that uses no intermediate model between the formal representation and the system that it represents. Now that contrast can be seen when you compare computer simulations that use a traditional scientific model, such as a differential equation model, and the simulation has to, at the least, turn that into a discrete model and then use numerical methods to apply it. So contrast that with simulations that are based on cellular automata in which the computations are applied directly to the representation itself. I'll give you an example of that in just a minute. Now, in a number of publications, Michael Friedman has argued for the importance of constitutive a priori principles in science. And we've had a lot of discussion of that, but let me just remind you of the main elements of this. These principles are necessary preconditions for the representation and solution of problems. And although they play a number of roles, all of which are deeply interesting, the aspect that I'm going to focus on here is their representational features. There are four components to Friedman's scheme. These are, first of all, the formal mathematical framework, for example, the role that Euclidean geometry played in the Newtonian framework. Certain fundamental scientific principles that constitute coordinating definitions, for example, Newton's laws of motion. Third, empirical principles, such as Newton's law of universal gravitation. And fourthly, philosophical frameworks that constitute the base of communicative rationality. Now, in his 2002 book, Friedman discusses elements of the Newtonian synthesis and says the following, which I found very striking. Without the mathematics of the calculus, Newton's second law of motion could not even be formulated or written down, let alone function to describe empirical phenomena. The mathematical part of Newton's theory, rather, supplies elements of the language or conceptual framework, we might say, within which the rest of the theory is then formulated. And it goes on to make a similar point about the role that the tensor calculus played in the formulation of general relativity. Now, Friedman's locus of interest is understandably large-scale revolutions in science, and as he mentioned yesterday, he himself refers to restrict the application of these apparatus to space and time elements of the framework. And certainly we have to respect that. So I'm going to simply draw on this as a sort of inspiration for taking off in a slightly different direction. So because of his interest in large-scale revolutions in science, examples such as the Newtonian and Einsteinian revolutions are, of course, appropriate examples. And within them, the constitutive a priori apparatus is formulated linguistically, which is understandable given the historical context in which it's introduced. But the point holds at smaller scales as well, and although we have to retain the computational aspects for my interest in computer simulations, there are non-linguistic computations and non-linguistic ways that our brain represents the world. And so, for the direction I want to go in, we need to look at more general representational formats.